Our new day, more practice. Today, I want us to look at some more examples of questions that you might see on a test or on an exam. Yeah. I'm picking out maybe 4 or 5 questions that I think represent the different types of compound fraction questions you're likely to see. Of course, they come in all shapes and sizes. The job for you today is just to understand our approach because it applies across the board. Cool. All right, now the first example is 1 and 1/3 minus 3 and 5/6 divided by 5 and 1/9. Now, I chose this question because there are no clear lines of, you know, demarcation in terms of what you need to do first. What operation comes first? And that is why we teach a topic called order of operations, right? The acronyms that we tend to hear are, let me see if I can get this down. BOMDUS, we hear PEMDAS, we hear BODMAS as well. But the idea is that the topmost letter represents the operation that you want to do first, right? So you're going to do brackets, multiplication, division, addition, subtraction, right? That's the idea. So in a question where you have brackets, the brackets will be done first, then multiplication, or division, addition, or subtraction. And I said or because we consider division to be multiplication by inverse, and we consider subtraction, and we can consider subtraction to be the addition of a negative. So that works, right? And the O, of course, is just so that it reads BOMDAS instead of BMDAS. All right. So having said that, in instances where we don't have brackets, then we do multiplication or division next. And after that, we do addition or subtraction, right? A more powerful acronym would be PEMDAS, which will be applicable in other questions. So let's just clear that to give you an idea of what that represents. So PEMDAS, the more I write, the more these letters look worse. Starts off with P for parentheses, or fancy word for brackets, E for exponents, but then goes back to what we know, right? Multiplication, division, addition, subtraction. These operations fall below both brackets and exponents. Brackets need to be worked out first. You can't do anything to something in brackets until you know what that thing is. And exponents need to be evaluated first, which means that you can't just work on the 2 in 2 squared. You'd have to work on 4 as a whole because you need to know what the entire value of that exponent is, or the final value, right? So this is our guideline to kind of how we work these questions. And if we're comfortable with it, then we should be fine. It's not heavy lifting. So let's get into it, right? For this question, our first step is going to be what operation is first. And we have here a division. So we're just going to bracket this because that takes precedence over our subtraction. And we're going to work on what we have now in front of us. And we should be fine. All right. I'm not evaluating this yet. I don't need to. We need to evaluate what's here. So we end up with 3 and 5/6 divided by 5 and 1/9. Let's convert these because we can't divide or multiply mixed numbers. Let's convert these to improper fractions. So 3/6 is 18 and 5 looks like 23. That is a 3, I promise you. All right. More effort. 23/6 divided by what looks like 9 times 5, 45 plus 1. 46/9. We're in a good place. We're making it time, people. All right. So we end up with 1 and 1/3 minus 23/6. And if we're dividing, it's the same thing as multiplying by the inverse of 9/46. Yeah. Now we can get closer to what we need to have. We can divide 23 by 23 here and 46 by 23 here to give us 2. Both 6 and 9 are multiples of 3 and so are divisible by 3. 6 divided by 3 is 2 and 9 divided by 3 is 3. All right, not bad. So what do we really have, right? We have, at this point, 1 1/3 minus, and we're multiplying across here. 1 times 3. Ooh, why is 3 giving me a hard time? Okay, I promise you I can write. Over 2 times 2. All right, so what we end up with here, subtracting something from something else. I'm just going to rewrite both of these terms, of course. This is our mixed number we're converting to an improper fraction. 3 times 1, 3 plus 1, 4 minus 3 over 4. And all we have to do now is what we're accustomed to, which is just adding fractions. And we know the rules for adding fractions. We can't add them unless they have the same denominator. Again, because the size of each of these parts, the size that these parts represent, is going to be different if the denominators are different. And so we need them to be the same so that they're comparable and can be added and or subtracted. All right, so we need to find a common multiple here. And I'm going to use the approach that I've been using, which is to just find a common multiple of denominator times denominator, because this is the approach we'll use in algebra. Of course, you can just write 12, but I want us to understand that this ties into equivalent fractions as well. So if I multiply the denominator by 4 here to give me my new denominator, I must multiply the numerator by 4. Likewise, if I multiply the denominator here by 3 to give me a new denominator, I must multiply the numerator by 3. We end up with 16 over 12 minus 9 over 12. Not bad, not bad, not bad. And we're almost there. All right, no, 16 minus 9 should be 7 over 12. And for a question like that, you would get 4 marks. I don't know if I've said this before, but your final answer is very important. Cool. But your steps are also important. You could get all the way to the end of a question and make an error. At the final step, your job is to make sure that you have those steps there so that the examiner, the marker, the teacher knows, hey, I was doing everything right up to this point. Clearly, this is a simple mistake. And so you've earned what we call the benefit of the doubt. Work in that way, and you should be fine. You know, simple mistakes are possible for everyone. Trust me, I make mistakes all the time. After these videos, 2, 3 takes. Yeah, not fun, but but we're doing it for the love, right? And the likes. All right, chronics. That's it. Let's find another question that makes sense for you guys. All right, I have one here that's a kind of like, because we just spoke about order of operations, right? So let's try this one. This one is, and let me write this properly so I answer the right question. 1 and 3 over 4, 1 3/4 all squared. My word, that is a 2. Can't take my word for it. Yes. All right, this is why my children see my writing and cringe. All right, let's work with it. So at this point now, again, this is, what are we doing? We're dividing something by something else. What is the thing we're dividing? We don't know until we work out the square here, the power, the exponent there, right? So again, this is in brackets, not because it's what we're working first necessarily, but because when we're squaring, we need for you to understand that you're squaring everything. And because this has been written as a mixed number, putting everything in brackets avoids any confusion, right? Now this is divided by a term that we're going to have to convert, of course, from mixed number to improper fraction, because you can't divide using mixed numbers or multiply. So our first step here is to evaluate. I'm just going to rewrite this as 4 times 1, 4 and 3, 7. Now, even in this form, I'd probably put this in brackets because I wouldn't want you to think that we're just squaring a 7 if we didn't have the bracket. The bracket is there to say that the entire fraction is being squared. So this is divided by, and we can work simultaneously on this side, by 3.5, which is 2 times 3, 6 and 1, 7 over 2. All right, we're almost there. We're squaring this, right? Now, this is 7 over 4 all squared. That is really 7 squared over 4 squared. Another way to look at that, which would be more applicable. I mean, We haven't done indices. So let's just look at this as 7 over 4 times 7 over 4, because that's what the shorthand, or the, what's the term? You have sub. I can't, there is a term. Anyway, super. Anyway, that's what the exponent, the power, is saying, that we're actually multiplying this term by itself. And I was thinking about the term in IT that we use. I know we have it's not subfix. I can't remember. It will come back to me one of these days. But what we're looking at here is 7 over 4 times 7 over 4 divided by 7 over 2. So I'll just put that 7 over 2 back for now until I evaluate this, just to emphasize the fact that we're not even touching this operation really until we finish with what's over here. So we get 7 times 7, which we know to be 49. 4 times 4, which we know to be 16, divided by our 7 over 2. And we know that this is 49 over 16. And if we're dividing by a fraction, it's dividing by anything. It's the same as multiplying by the inverse. I know life is easier, yeah? And my dog starts barking, because such is life. All right, now, what's common to 49 and 7? 7, of course. 7 divides 49 to give you 7. 2 divides 2 to give you 1. 2 divides 16 to give you 8. And we end up with 7 over 8. Felt like I was trying to be stylish there and messed it up. Anyway, that's our answer for that one. How many marks would a question like that net you? That's about 3 marks. It's really short. What made it seem a little bit longer is us, putting in a lot of steps. All right, so let's get to, if we can, maybe 2 more. Might not get to the 5 questions, but we definitely will get to 4 minimum. Yeah. All right, so this one, I kind of like this one. This one is 1 3/4 minus 1 over 8 plus 5/6 divided by 2 over 3. Now, how many marks is this question? It's a 3-mark question. So it's a real quick one too. Now, we can't add anything. We need to know what's in the bracket, so we need to evaluate both brackets. So let's get that done. Here we have our subtraction, but I'm converting from mixed number to improper fraction. So we end up with here 4 times 1, 4 plus 3, 7 over 4 minus 1 over 8 plus what looks like 5 over 6, and I'm dividing here, so I'll multiply by 3 over 2. So not a difficult question, but it's just about how comfortable you are working with brackets and mixed numbers. And I think a lot of these questions just throw these things in here, the mixed numbers, in order for you to feel a bit, agitated by the fact that it looks a little bit, it doesn't look as simple as working with proper fractions. And so they throw more operations in there to kind of check to see if you're comfortable. But these work out nicely, as they should. You won't get any wonky fractions, ideally, because your teachers would have worked out the questions ahead of time. All right, so let's go. No, I am going to do something a little bit different. Before I'd write the denominator down here and write the separate fractions, but it's an equivalent fraction situation, right? This is 8, and 4 does divide 8, so I can just rewrite this fraction as an equivalent fraction. I can multiply this 4 by 2 here and this 7 by 2 here, and that would give me 14 over 8 minus 1 over 8, right? Because I don't have to change this fraction. This is a factor of this, so I can literally write the equivalent fraction for 7 over 4 with a denominator of 8, so that I can then subtract, in this case, these 2 fractions, right? Over here, we ended up with what was common. Well, we can't cancel. There's nothing common to 5 and 2 apart from 1. But I can divide 3 by 3 to give me 1 and 6 by 3 to give me 2. And I'd end up with 5 times 1. I'll just write it for the sake of writing it. 5 times 1 over 2 times 2. All right, we're almost there. We are close to the end. So we end up with 13 over 8 plus what looks like 5 over 4. All right. But again, denominators are very similar. Some of you would say find an LCM. Let's just work with the concept of using equivalent fractions, right? We leave our 13 over 8 all by itself. It's alone. I can multiply this 4 by 2 and I can multiply this 5 by 2 to create the equivalent fraction of 10 over 8, which when added here gives me 23 over 8. I need to, this 23 looks very special, but let me check this. Let me fix this up. Give me some space here. All right, so we're looking at 23 over 8, or we can write the mixed number there. We can go, 8 can divide 23 two times, and that leaves a remainder of about 7 over 8. And for this kind of question, we're looking at, like I said, 3 marks, so it's a really quick one. The heavy lifting was just that it looks a little bit different, right? And the exams are getting easier, so the closer you get to, as you're working out your past paper questions, the closer you get to the current year, the easier the questions become. All right, well, one last one. This was a question from an exam in 2024. Extremely short question, actually a 2-mark question. So even the amount of marks allotted are less because the questions are getting easier. So you're not getting anything too detailed, nothing too in-depth here. So you have 1 minus 1 over 30. This is our last one. Gentle people plus 4 over 15. I can see why this is a 2-mark question, but I won't keep you much longer. So it's going to be 1 minus, I have to work out what's in bracket here. We'll have the 1 over 30. Let's write this fraction as a fraction over 30 as well, using our equivalent fractions. We end up with 8 over 30. One of those days. Yeah. So we end up with 1 minus what looks like 9 over 30. And what's left here should be 21 over 30. Can this be simplified? You should simplify. What is it divisible by? Your divisibility rule should tell you that's divisible by. Your timetable should tell you that. Times table should tell you it's divisible by 3. But also divisibility, because I can add the individual digits to find out whether or not a number is divisible by 3. Here I can go 2 plus 1 is 3, so that's divisible by 3. 3 plus 0 is 3, so that's divisible by 3. 3 sevens 21. 3 tens 30. But in general, well, this is our answer, but in general, if you want to know if a number is divisible by 3, you add the digits. So, if I write 1, 8, and 1 and 8 is 9, and I add 3 to that, right, I should get 12. This is divisible by 3. Yeah. If you write 2, 4, that's 6, 0, 9. How much am I at now? That look like 15, 3. 24,093 is divisible by 3. Whatever you're writing, once the sum at the end, the individual digits sum to 3, that number is divisible by 3. All right, not keeping you much longer. We ended on a low note because it's a 2-mark question, but again, we just wanted to see different types of questions. There is a game on the website that should relate to this. I will likely need to work on that game a bit, but feel free to try the games on the website. Q&A math. Let me write it down. Q&A math.com. I swear my writing gets worse and worse every time I do this. But don't forget to like and subscribe, gentle people. I will see you in the next one. We are more likely moving on to something else, maybe indices. But we'll see how that goes. Thanks for watching along. And again, enjoy doing this, and hopefully it's helping you work out any issues that you may have. Have a great one.